Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 7 Notes 2. Today we are talking more about the normal distribution that we talked about yesterday in Notes 1, Lesson 1. But today we're going to look at inequalities. So we're going to talk about different sides of the curve today. Yesterday we talked about just how to look those things up in the probability table that you have, the Z table, talking about what a Z-score is. But today we're going to talk about when do you look at the left side, when do you look at the right side, when do you talk about the middle, things like that. So hopefully, if you haven't done so already, please grab that blue Z chart so that you can follow along with your blue Z chart while you are listening to this video. I don't have screenshots of the blue Z chart in my slides today, so hopefully you have your blue one next to you so that you can follow along. There's that normal Z chart again, and remember, normal distribution has to do with the bell curve, that we've got 68% of our data within 1 standard deviation of the mean, 95 within 2 standard deviations, 99.7 within 3. The probabilities are shown in the table. You've got a negative side and a positive side. The negative side is less than 50%. The positive side is greater than 50%. That's just a reminder from yesterday's notes. All right, so let's take a look at the area under the curve, the standard normal curve that fits the following. So all of these are going to be less than. So we are looking at, here's our normal curve, and I'm going to try and draw you some pictures for this. We've got a normal curve. You know, your mean is in the middle. When you standardize it, your mean is 0, and then your standard deviations are 1. So this is +1, and then over here, your standard deviation is -1. So if you are looking at the area under the curve that is less than Z equaling 1.41, the marker that you want is positive 1.41 on your curve. So for me, that's right about here. Now, I'm looking at all the probability that's less than that. That means that I'm looking at this entire shaded region to the left. Less than means to the left. This line is just like a number line like we've been looking at for years and years and years and years. If 0 is here, you know, it increases to the right and it decreases to the left. It goes negative to the left. So the area that's less than is that entire purple shaded region. So lucky for us, the table gives us that. So look it up in the table. So in table A, I'm going to look up my probability and see what I have that's to the left of that line, that Z equaling 1.41. So when I look that up in my table, I get a probability of 0.9207. That's the probability that's to the left. And if you look at that purple region, it's pretty big. It makes sense to me that that would be 92% of our data because that's a big region of our table. All right, so let's do a new graph here and look at the next one. So Z is less than 2.08. 2.08 is really up high on our normal chart. So let me go back to my normal curve. Here's my mu of 0 or mean of 0. 2.08 is up here, like way up at the top. And again, I'm going less than, so I'm way big region all down here. And then I want to find what that probability would be. If you look at that purple region again, we should expect it to be kind of a big region. So for 2.08, I'm looking at 0.9812 for a probability there. So P equals 0.9812. So that means that this region right here is 98% of our data, 98.12% of our data. Okay, so let's take a look at the third one. Now I'm going to draw my curve again. So my normal curve looks like this. Here's my normal curve. I draw these a little bit different every time. Sorry. Now I'm looking at Z equaling Z being less than negative 1.79. So negative 1.79 would be out here somewhere. This would be like my Z equaling -1. This would be negative 1.79. So I'm looking less than that. It's a pretty small region. I'm only looking at that tiny little piece right there. So if I look at that tiny little piece in my table, go to negative 1.79, just like you did yesterday, and type and look up the probability there. And I get a probability of 0.0367, P equaling 0.0367 approximately when I look up in that table. I'm actually doing these probabilities on my calculator. So if mine are looking like just like 100th off from what yours are, that's because I'm typing them in on my calculator instead. Let's look at negative 0.23. If I do negative 0.23, I'm just going to change my colors and use the same graph. Negative 0.23 is just below that mu equaling 0, right about here. So I imagine this would be, somewhere in the 40-ish% of our data. If I try to find that one in the table, go to negative 0.23 in your table and see what's underneath it. It's going to be close to the 50% mark. I see 0.4090 for my probability there. 4090. Okay, so bottom line, left side, when you see less than is the left side of the curve. That means you're looking to the left. That's given to you in the table. These are given to you in the table. You don't have to do anything special. Now let's talk about greater than, because greater than is a little bit different. If I'm looking at greater than, that means I'm looking at the right side of the curve. Well, here's the thing. The table doesn't give us the right side of the curve. The table gives us the left side of the curve. So if I'm looking at z equaling 2.41, I'm like way up here somewhere. I'm looking at this little region. So this is z equals 2.41. And the area greater than that is to the right, okay? Greater than means above, and above goes to the right. What we have to remember is that the whole thing, the area of this whole thing is 1. So if we look in our table A, okay, you go to table A, and you find the z, that's going to give you... that gives you probability less than whatever your z is. You want probability greater than. So for probability greater than, you need to take 1 minus whatever the probability in the table gives you. Because you're going to get, in the table, you're going to get this whole region. You want this region. I want the region above it. So I need to take 1 minus to get my z. So if I do that, go to your table, look up 2.41. So 2.41 gives me 0.9920. So 2.41 gives me a p-value of 0.9920. So then I need to take 1 minus that answer to get the probability I want. 1 minus 0.9920. If you don't have your calculator out, you're going to probably want that. I get 0.0080. So the probability you have there is 0.0080. And it makes sense in our picture. This is a really small region of data. It would make sense that it's about 1%. It's a really, really small piece. Okay, let's try the next one. So now I'm looking at z equaling 2.18. So 2.18 is going to be right about, here-ish. And I want this piece up above. So go into your table and find what's below the 2.18. Look up 2.18, see what's measured to the left. Measured to the left is 9853. And if I take 1 minus that, I get 0.0146 for a probability there. So my probability is 0.0146. So again, I went to the table, I found the probability, and then I took 1 minus. Let's do the negative sides. Now we're down here. I have negative 0.79, which is right about there, not quite to -1, and I want what's greater than that. Okay, so take a look at your region. This is a pretty big region. This whole right half up here is 50%, plus I've got this little piece right here. So 50% plus that, I'm going to be at about 60-ish%. So if I put that into my table, I get 21% that's over here to the left, but then I have to take 1 minus that and see what's above it. I get 0.7852. So probability is 0.7852. And then negative 2.23 is way down here. And I want, it's out even further, like way down here. And I want this entire huge region up to the right. I want all the things that are above it to the right. Since it's up to the right, it's going to be a really small tail that you find in the table. And then 1 minus that. I'm envisioning being in the 90% right here. So I'm going to do that one more time. Look up negative 2.23 in my table. I get about 12, 13-ish% there, and then take 1 minus that. I've got 0.9, sorry, not 12%, 1.3%. Move my decimal 2 places, not 1. So 0.9871 is my probability there. So probability is equal to 0.9871. So bottom line here is when you have greater than, you want to take 1 minus whatever the P is in the table. Okay, so now let's talk about finding the area between two values. So if I'm looking between two values, let me just draw you a little curve. Here's my curve for this one. I want to look between z equaling 0, so that's this piece, and z equaling 2.3. So this is approximately the region that I want. What is the P, or what probability is in that red region? This is z equaling 2.3 here. What you have to do is you have to find both of these and then subtract them. So you're going to find 2.3, which is going to be a big chunk, because think about it. If you find the 2.3 includes all of this. But then you're going to subtract off the 0, which is this piece. And when you subtract off that purple part, you're left with just the red, which is what you want. So my probability for z equaling 0, I already know this one, is 0.5. That because z equaling 0 is the 50% line. So let's go to the 2.3. So 2.3 is going to give me 989. This is 0.9893 there. And then I need to subtract those two. And I get P equaling 0.4893. So that's that red region that's in the middle. Let's do it again. So if I do it again in part B, here's my curve. So I'm looking at between negative 1.34 right here-ish for my Z, and 2.23 up at the top. And I want what's between it. So that means I need to find both and subtract. So if I look up negative 1.34, this one gives me P equaling 0.0901, and then 2.23, that one gives me 0.9871. And then subtract the two, 0.9871 minus 0.0901, and I get 0.8970. All right, let's look at C. So I have 1.12 to 2.01. 1.12 is right, this is my middle. So 1.12 is right about there. And 2.01 is right about, just not that far above it, 2.01. So I'm looking at a really small region right here. That green region that's between those two is pretty small. I don't expect a high probability here. So if I look up 1.12, go to your table, find 1.12, I get P equaling 0.8686, and then I do the same for 2.01. 2.010, 0.9778, And if I subtract those two, minus 0.8686, I get 0.1093. So only 10% there. I envisioned a small probability in that because that region's really small right there. So I didn't imagine I'd have a whole lot. 0.109, oops, sorry, hello, put my 1 in. 1093 is my probability there. The last one, I'd be negative 0.68, which is not that far below the 0. 0.68 down to negative 2.32, which is pretty low. Here's the region I want for that one. I'll look them both up. I imagine that'll be in like the 30-ish%, 30 to 40% mark, something around there. So look up negative 2.32 in your table. And again, if you don't have your table out referencing this with me, I hope you can figure out how to find these things in your table later, because that's going to be really helpful for you. So this one is P equals 0.0102, and then negative 0.68. 0.68. This is 0.2482. Oh, and it's even less than what I thought it would be. So 0.2482 minus 0.0102, I get 0.238. 0.2380. That's the piece that's between. Okay, so between, the bottom line here is find both and subtract. So if you need to write that down, make that little note for yourself. Find both and subtract. Okay. All right. Let's take a look at the next example. So let's talk about some extreme z-scores here. So our z graph, our normal distribution graph looks like this. Mu of 0 is in the middle. This is the standard normal curve. If I do my z-scores out, I'm about 1, about 2, and about 3 way out here. Negative 1, negative 2, negative 3 way out here. So the bottom line is 99.7% of your data is from negative 3 up to 3. There is not a whole lot of data when you get out to 5.5 z-scores way up above here. You know, that would be way out to like 5.5, way up there. And 3.49, same. Not a whole lot of data, okay? 3.49. So nothing is outside, which means everything here is going to be to the left. Same with the negative side. Negative 4.46 is way down here. There's like virtually no data. I can't say none because some does exist, but it's so small that we don't even register it on that z-score table. You will notice that your table doesn't go out to these extreme values. You're not going to see them in your table because they don't have anything outside of them. So if you're looking between z equaling 0.04 and z equaling 5.5, well, guess what? Positive 5.5 way up here includes everything below. So my probability for positive 5.5 is 1.0, essentially. It's not exact, but that's what we round it to because the probability that's above it is so small that it doesn't do anything for us. So then let's take a look at 0.04, because all I need to do here is find 0.04 and subtract the two. So my probability for 0.04, if you go to your table, go to 0.04, it should be just above 50%. Because basically what I'm looking at is 5.5 to 0.04. I want this region. Okay, I want that region of data right there. So find your 0.04. And that's like I thought, just about 50%. So 0.515, so 5160. And this is probability of 1, and then subtract the two. 1.0 minus 0.5160. So the piece that's between is 0.4840. That's my probability there. Let's take a look at this one. If I draw a normal curve for this one, here's my mean. I'm looking at 3.49, which is way up here, way up at the top. And then negative 4.46, not even like measurable. It's not even on our chart, way down here. So guess what? The data that's between these two is essentially the entire curve. this is a probability of 1.0 because there's such small data outside of the negative 4.46 and such small data outside of the positive 3.49 that essentially everything else is between them. So 100% of our data is going to be between those two z-scores. So that's just a brief discussion on these extreme z-scores that are so far away that they don't have really any data measurable that's outside of them. This is just another way to read those. If I were to go through and find all of these would be between, again, I'd be looking at mu equaling 0. I want 3.28, which is way up here, and 1.26, which is right about here. And I want this region. So for all of these, we're going to find both and subtract. And subtract. This compound inequality, that's what this thing is right here. When you have the variable in between with two inequality symbols, that's called a compound inequality. And that compound inequality is a fancy way of saying between. So you want the data that's between those two values, and you find both and subtract. That's how we find it. This is just written out in notation instead of written out in words like we saw it on the last screen. I'm not going to do these other two. I can help you with them if you have more questions about that. But essentially, you'd find both and subtract, find both and subtract. That's going to take us to the end of our notes for today. Thank you for listening, and let me know if you have any questions. I'd be happy to help. Go ahead and work on your practice assignment, and I will catch you for our next lesson video. All right. I think that is a typo from your practice assignment, so take a look at that and see if you need to fix that. It might have already been fixed, but you can check it out.